Hi, everybody, and welcome to our first honors chemistry notes. As you can see, I'm going to be recording my notes from my screen. This is a pretty low-tech way of doing this, but it should be very straightforward. And from the notes in your packet, you're going to fill these out as you go along. Obviously, please feel free to pause anytime you need to, all right? And also pause when it's time to do a practice problem. Okay, so let's get started. All right, so chemistry is the study of matter. Matter is anything that takes up space, all right? Something that's really important to chemistry, and we're going to be talking about all of the time, is the fact that chemistry is a quantitative science, which means that we do a lot of describing using numbers. Okay, as opposed to a qualitative description, which is a description without numbers. So for example, if I were to ask someone how tall they were, okay, they could tell me that they are 5 feet, 11 inches. That is a quantitative description of their height. All right, and the idea is that I could measure their height, you could measure their height, and we should get the same thing depending on the tool we use. I could ask someone their height and they could say I'm tall. Well, to some people 5'11" is tall, but to some people 5'11" is not so tall. So while qualitative descriptions, they certainly can be good, sometimes they are not agreed upon by everyone. All right, so as we go, all right, here we go. All right, so almost all of the numbers that we're going to be dealing with in chemistry represent a measurement. Therefore, they must be labeled. And by labels, I mean they have to have units. All right, we're very accustomed to math where the only thing in math is the numbers you're dealing with. That's not the case in chemistry. We are very interested in not only the mathematical answers that we're going to be getting, but the label, because these numbers represent something. As far as these units go, we are using the SI system, which stands for System International, which sounds much better with a French accent, all right? And these are very similar to the metric system, although there's a couple little differences. The base units, all right, are as followed, and you want to fill these out in your packet. For length, our base unit is a meter, and the symbol is a lowercase m. For mass, technically the base unit is a kilogram, all right, and the symbol for that is kg. So why is it a kilogram and not a gram? Just because a gram is such a small amount of mass, all right? But we will be dealing in grams quite a bit, and we'll talk about that in a moment. For temperature, according to the SI system, we use the Kelvin scale. That gets the symbol capital K. Time is typically in seconds. All right, and amount of substance, which we're going to talk about a whole lot later on in this class, is a mole. All right, let's talk about some of these different base units. Okay, length is the distance between 2 points. The tool that you would use to measure length is simply a ruler. All right, it could be a measuring tape. And as we mentioned before, the base unit is a meter. Mass is the amount of matter an object contains. The tool that we use to measure mass is a balance, all right? The SI base unit is in a kilogram. We're going to be using grams because in chemistry, we tend to use very small amounts in our labs, so we will be talking about it in terms of grams. Temperature is defined as the average kinetic energy of a substance. Great, you guys know this. You're going to use a thermometer to measure temperature. We use Kelvin is our SI unit, but when we make measurements in labs in chemistry, we will be using Celsius. We will talk quite a bit about Kelvin later in the year, particularly when we are dealing with gases. All right, for time, I don't have a definition for time there because honestly, lots of people can argue the definition of time, but time is certainly something that a clock measures, and that's what we will be using as our tool. So these are our base units. If you combine base units, you get what are known as derived units. So let's take a look at our derived or combined units here. If Miss Adani can get her computer to scroll well, there we go. All right, so our first one to talk about is speed, and we are used to speed because we're used to driving in cars, and we talk about how fast we are going, all right? And speed is distance over time, or in terms of the base units we were just talking about, length over time. So you'd get something like miles per hour in our car, all right, or centimeters per second, all right? We also use length For area and volume, again, these are things you're used to from math. Area is just simply a length times another length. Example of a unit there would be a centimeter squared. Volume, we remember it as, length times width times height, all right, or however you learned it in math, but really those are all lengths. So it's like the first length times the second length times the third length, and we would have that in centimeters cubed. A little note, and something for you to definitely star in your notes, is that a centimeter cubed is the same thing as a milliliter. Those are both volume measurements that we are going to use all of the time. All right. And then finally, for our derived units that we're going to finish up with, we have density, which is the mass of a substance divided by its volume. All right, so for density, you're going to have masses in grams, volume centimeters cubed. An example of a density unit would be grams per centimeter cubed. Okay, great. All right, let's move on a little bit here. Okay. Something else that you are going to be responsible for, but we're not going to spend a huge amount of time practicing, so this is going to be one on your own, is making sure that you are comfortable with the metric system. In your textbooks, this is on page 74. You can look this up anywhere. Right here, this is the important part. You must know and be really comfortable with these 4 units: kilo, deci, centi, and milli. There are a lot of other prefixes, pico, nano. You don't need to know those. You need to know kilo, deci, centi, and milli. I'm going to kind of talk through the way that I memorize this. You can certainly memorize it any way you want to. All right. I kind of base everything on the base unit, okay, and memorize it as that goes. So I'm actually going to start going down. All right. So if for example, talking about a meter, well, in 1 meter, there's 10 decimeters. In 1 meter, there's 100 centimeters. In 1 meter, there's 1,000 millimeters. That's all I do to memorize it. Some people like to memorize it using, 0.001, however you want to do it, but you do need to be familiar with that. I also like to always think of it as which one's bigger. So a kilometer, I know a kilometer is bigger than a meter. Remember, a meter is about a yard. It's about a yardstick. A kilometer, think about people who run like 5Ks and things like that. That's a much longer distance. So a kilometer is bigger than a meter. So in 1 kilometer, I know that there's 1,000 meters. There's 2 little practice problems there in your notes. Go on ahead and pause this if you'd like and give those a try in converting. All right, so how many grams are in 250 kilograms? Well, I know that gram is a tinier unit, which means that in 250 kilograms, I'm gonna get a lot of grams, all right? So there's also ways people like to remember this just doing zeros. There's 1,000, all right, in 1 kilo. So I'm just gonna add 3 zeros from 1,000, 3 zeros here, and I get 250,000 grams. How many meters are in 2,540 millimeters? Millimeters are teeny, teeny, tiny. All right. And so I'm not going to have as many meters. So I'm going to move that. And I think to myself, all right, well, in 1 meter, there's 1,000 millimeters. So that's three spaces, 3 zeros. And I'm going to move that decimal place over to give me 254. Again, please do whatever makes you comfortable with converting your metric, but always watch out for the units that I give you in a problem, all right, and what I'm looking for as an answer. Okay, let's go on ahead. And now we're just going to play a little bit with our calculators. Scientific notation. Scientific notation is different than just exponential form. For scientific notation, you must have 1 digit, then the decimal place, then however many digits are left, then times 10 to whatever exponent. All right, so for example, if I give you this regular number, okay, 25,805, and I want that in scientific notation, I'm gonna write 2.5805, right, because a single digit, decimal place, everything else, and then I had to count over 1, 2, 3, 4, so that's times 10 to the 4th. Same thing works when you're going in the opposite direction. If I had given you 0.00754, I'm going to have 7.54, because again, digit, decimal place, everything else. This time though, I took that decimal place and I went to the right. 1, 2, 3. So that's to the -3rd. Okay. All right. The last thing with scientific notation is using your calculator. Many of you have been using your calculator incorrectly for scientific notation. This is what you should be putting into your calculator, and I'm going to come down to my actual calculator here and show you what I'm talking about. So let's go down to Mrs. O'Donoghue's calculator. All right, so let's say I want to put in this number, 2.5 times 10 to the fourth. All right, so what am I going to do? I'm going to zoom back here so you can see. 2.5, make sure I'm on, yeah. Second, then I go down to the EE button, which is this comma button, EE, and then 4. That's it. That's all you put into your calculator. All right, some of you have been using carets. Don't use the carets. Please use the EE button. We will talk about this quite a bit as we go on, but really this is by far the best way to put things into your calculator. All right, today is kind of a hodgepodge of notes, so we're going to go over, this is our last slide for today, and this is what we call dealing with measurements. You're going to be doing a lot of measurements and a lot of calculations, and we're going to be asking you, how good are they? All right, so questions that you might be asked, that we might ask you is how accurate they are or how precise they are. All right. Accuracy refers to how close your measurements are to a known value or a true value or the accepted value. Precision is how close a set of measurements are to each other. Okay. One way that you're going to tell us how accurate you are is by doing what is known as percent error. All right. Percent error is very simply the known, the true accepted value. You're going to subtract your value. By your, I mean the student's value. What did you get in the lab? You're going to take the absolute value of this. So it really doesn't matter which one of these goes first. What really matters, though, is what goes in the denominator. It must be that known, accepted, true value. That's what we're comparing it to. And then you're going to multiply that by 100. And that's just going to give us an idea as to how well the experiment went for you. All right. So I think you have a practice problem there. So why don't you go on ahead and pause, and we will see the answer in a minute. Okay. All right. Now we're back. Here we go. You calculated the molecular mass of carbon to be 13.1 AMU. The known value is 12. What is your percent error? So you should have gotten about 9.17%. We're going to talk about rounding in our next note, so please don't stress over that. All right, so you did 12.0 minus 13.1. I took the absolute value of that. You're going to divide that by 12, and then you're going to multiply it by 100. Because this is always an absolute value, your percent error will always be a positive number. Why did I have 12 in my denominator? Because 12 is the known value. All right. And then your percent error is therefore about 9.17%. You want your percent error to be as low as possible, okay, in a lab, obviously, but sometimes that doesn't work out. All right. So I know this has been a lot to digest today. Please go through these notes again, and you're going to have a chance to practice all of this material. Have a great day.